Deji, are you ready?
Yes, you can go.
Okay. Yeah, good evening all. My name is Yemi Ayola. I'm a software tester, and currently I work with an insurance and asset an insurance organization. I work as a senior test lead, and I've been into testing for almost a decade now. And I've worked in several organizations. So, financial technology, investment and asset, insurance, government, and the likes. I'll be taking you on manual testing, which is software testing, into it. And I hope you all enjoy the class, and we'll see how it is. But for today, the first thing I want you to understand is that I'm going to go through these the course with you, and as I'm going on, there are things I would like you to just take on board. We've just got 2 hours. Please ensure that you concentrate fully in terms of listening, paying attention. Then you can actually follow up with the class. The second thing is, at any point in time, if you have any question, just pop it into the chat. There are people ready to actually answer the question. I will also go through the questions and answer too, so that at least we can go on and get everything we need in terms of understanding and carrying it. So any question you have at any time, there's no silly question, just put it on the chat. We will answer it immediately. And I hope you will all enjoy the class and all the best. So I'll start by sharing my screen. So please, can you give me permission to be able to share the screen, please?
One minute. Can you try now? Hold on. Can you talk? Let me see which one.
Okay, this is me.
Okay, cool. All right, cool. Yeah, can you talk? Can you try now, please? Okay, cool.
Okay. I hope you all can see my screen now.
Yes, please.
Oh, great. Okay. So, introduction to software testing. Software testing. So the first thing I'm going to take you through is the background of testing. And what in terms of testing is just for me to ensure that, yes, you know the reason why we test, what are the things that we test, how is testing done. You've been hearing about software testing, you've been listening to software testing, you understand everything. Of course, I don't know what the course is about, I don't have an understanding of it, hence the background of the testing. So the first example I like to give is, for example, if you get a new car, you want to buy a car. Now, the first thing you want to look at in the car, you have seen the model you want to on the internet, or you have seen everything you want. Oh, this is a brand I want XYZ brand. Okay, let me book to go to the showroom to view the car. Now, if you want to buy a car, there are certain things, essential components, features that should be in a car. That's the first thing you understand, that, oh, I want to get a car. What are the things that you need to have in a car? A car should have a steering wheel. It should have a wheel. It should have an engine. It should have a horn. There should be a brake, doors. All these are the things that build up and form a vehicle or a car that you see. Now, take for instance, you get to the showroom. You said you want to buy a car, and you get to the showroom and you enter the car. Oh, this car doesn't have an engine. Of course, this is not a completed car. That's because you said a car should have an engine, it should have a steering wheel, it should have this, it should have the doors, brake on. So before you want to buy those car, even if it has, you cannot get there, it has an engine, it has an on, it has everything. You still need to test the car. That is why you test drive the car. You need to see what are the features of the car, what are these. There are several cars, there are millions of cars outside there. So what is the thing I'm paying for? Why am I getting the car? This car, these are the features that I have in it. You still need to test the car. If you start the car and it's not starting, you won't buy it. You will leave the place, you won't get the car. Likewise, if you go to a phone shop or you want to buy a phone, the first thing you need to know is that, oh, I want to get a phone. What is the make I want to get? What are the features in the phone? You need to test it. You want to own it. Of course, can I call? Can I do this? What are the things I need to see on the phone? What are the essential components on the phone? That's before you can buy. So you need to test if the phone is working as expected. So if you are told that this phone, if you put it on the floor, is going to do this, is going to vibrate, is going to do, you want to see those components. So you want to test it. That's why testing is needed also. Now, I tell people everything, there is nothing new under the sun that wants to come out, that want to come out again, that you actually need, that is not in the world. If you want to test a car, there are 1,000 and millions of cars outside there. The only thing are just the new features they are adding into it. Talk of a mobile phone. We have several mobile phones that you want to test, so it's already there. If you want to talk about a website, there are millions of websites. When you Google, you can get examples there to be able to test. So hence testing is done in various ways. So we have I'm going to there are some textbooks we recommend for software testing in terms of learning and of course reading. So you get more examples of the background and testing in the textbook. So we've got a soft copy that we can share out to the team, and if you're interested, we can give you that. And while I go ends. And lastly, the example I'll give on background is maybe when you sleep in the morning, you sleep overnight, when you wake up in the morning, we all do some stretchings in terms of, oh, I stretch my body, stretch my hands, what are you doing then? You're actually testing. So testing is done in every phase of our life. So it's part of us. So we test everything. If you want to use a pen, naturally, just for you to be able to ensure that the pen is working, you scribble it on the paper. Then it tells you, oh, this pen is working. What are you doing? You're actually testing. So at every phase, whatever you do to ensure that, oh, this is working as expected, what you're doing is that you're testing. So that's the way it goes for the background. So the topics we are going to cover are the fundamentals of testing, testing principles, test process, code of ethics, testing life cycle, test level, test type, static testing, test case design technique, and test management. So what are the objectives in terms of testing? What is testing? How is testing done? Why is it necessary we are testing? The general principles of testing, fundamentals of testing. And in the textbook also, we have self-assessment questions. Likewise, I'm going to ask some questions. And as I said, if you have any questions, you can actually pop it into it. So same graphical way, what is testing? Why is testing necessary? General principles of testing, fundamentals of testing, self-assessment. So now, testing. This is an activity that is performed to demonstrate that something is working as expected. So now you get to a phone store, you want to buy a phone, and you get there, you switch on the phone, and they said, oh, this is the phone, is working as expected, everything is fine. When you switch it on, it's not coming on. and you were told by the sales assistant that, oh, this one is working as expected. Don't worry, just switch it on, and it's not switching on. Then it's not working as expected. Okay, now it's working, it's switched on. There are some features that you're buying, and that's why it's listed on a leaflet. You're looking at the features and you can't see them on the phone. Is it working as expected? No, it's not doing what you're telling me is on this leaflet, so I can't get the phone. That is why when you are testing, it's an activity to demonstrate that whatever you are testing is working as expected. So if what is on the leaflet is that this phone that you are holding that is in your hands, this brand must have a feature called search, and it must be able to search at every. So you want to see every feature to every letter written in the leaflet. So if it's not there, if anyone is missing, then it's not working as expected. You won't pay for that phone. So that's why we say this is an activity that is performed to ensure that something is working as expected. It's testing for me. Now people will say, oh, testing, who is it for? Maybe it's for specified people. Then let's find out who testing is for. So testing. Now, who is a good software tester? What attributes does a good software tester? Just like what are the attributes of a good tester? The first thing is verbal and written communication. You must have a passion for what you're doing in terms of testing. Anything you want to do, you must have a passion for it. Technical skills in terms of technicality. Hence, we are still moving on to automation testing and the like. So you're talking about testing, technical skills, analytical skills, your attitude towards it, and also the productivity. These are what entails about a good software tester. Then testing as a discipline, which means as a tester, who can you be? I'm saying I'm a software tester. What other title is ascribed to that name, software testing? Then you're talking about, you could be a tester, you could be a test analyst, a test engineer, a software tester, mobile tester, performance tester, web tester, security tester. You could be a penetration tester, UAT tester. All these are what testing as a discipline is. So this is the job that we do as a software tester. Testing, testing as a discipline. Inquisitive, you must work smartly, you must think out of the box, you must be patient and attention to details. So in terms of working smartly, organizing, prioritizing your work, knowing what to do, think outside the box. You want to test the phone. Don't wait that all the exception. You need to do both the positive and the negative testing to ensure that it's working as expected. Then you need to be patient, of course. You do the happy parts, you do the negative parts to ensure that you're balanced in terms of rates, the quality, and that, which we are going to talk in details with. So, and also, please do not forget, any question you have at any time, pop it into the chat. My colleagues are there to actually help out and answer your questions quickly. So who can test? Anybody can test. As long as you pick up a phone, or you can drive, you can test. As long as you open up a website, you are searching, going to Google, anybody can search. It's not rocket science, so anyone can search, they can test. What can be tested? Hardware, software. Hardware, physical devices, something you can touch and see, e.g. laptops, those are the hardware. Software cannot be touched or seen, e.g. internet browsers and games. So these are references. These are type of references in terms of more tools. Even if you go online to Google, you get different tools which you can actually use to test. So we just put a couple of references here for software testing. To be honest, this is like more of a crash class just to ensure that you all have an overview about this. In details of all this testing at the internship is going to be more detailed, is going to be on the granular level to ensure that you understand is a one-to-one one. So I just make sure that all this is carried on just for 2 hours to ensure everything, you still have an overview of it. But the internship, I am very sure that everything I have here are going to be in detail in terms of all the checks. Everything that covers testing will be taught more intensive there. So I'm hoping to see you all there. Yeah. Then software testing. This is an activity that is executed to demonstrate that a software, that's maybe a program, a system, a web application, a mobile application, is working as expected. So if you know, since I've been explaining, giving examples of testing, I'm ensuring I'm using the word that is working as expected. And the reason for this is that to ensure that yes, any software you are being given is working as expected. Now, how do you know that is working as expected? We will find out as we go on in the class. Sorry, please. Sorry. So software testing is not complex. Please, can you unmute, please? Adenika, thank you. So software testing is not complex, is not difficult. Yeah, thank you. It is not difficult. Hello, can you hear me now? So software testing is not complex. It is not difficult to implement, execute, and practice. Software testing is a discipline. How can a software be tested? Manually, automatedly. So we are talking about manual testing and automated testing. Manual testing, that is the foundation of testing. Before you can do automation testing, you need to have a background in manual testing. So we are doing manual testing class now. In a couple of days, there will be automation testing, which is for automation. But for this class, we are doing manual testing. So why manual testing? Manual testing, testers execute test cases with any tool, without any tools. That is manual testing. So you are going to see when I give you examples why we are automating without any tools. But automation, a tester executes test cases with a tool. So why do we test? We test to avoid software failure. So before an application or an app, or a mobile application, a website, a phone, a car is brought out, the first thing is that we want to ensure that it's properly tested before it's taken out. Take an example. If you just build a car, and when the car is not tested properly, it doesn't have a brake, it doesn't have, and you put it out there and someone should drive it. The first thing is, if you take it out, you could be driving it and no brake, to be able to stop. Then loss of life. If you've got a website not properly tested in terms of payment, there'll be loss of money, loss of business reputation. All these are part of the things that we actually need to test properly to ensure that, to avoid software failures. Hence, that's why we do testing. So a system needs to be tested adequately, and the right sort of testing needs to be done as well. Consequences: loss of money, loss of time, loss of business reputation, injury and death. There is a level of risk acceptable for any software. That is, if you're testing an airline application, the way you will test it is different from the way you are going to test a financial application. It's different from the way you're going to test an e-commerce application. So we have it, the way you're going to test an app determines on the risk, the type of application you're actually testing. So that you have to bear in mind when you are doing, when you're testing generally. So next I'll go to error, defect, failure. What is error? Error leads to defect, which can cause an observed failure. Error is human mistake. Anyone can make a mistake. So error is always human mistake. An error appears not only due to logical mistake in the code made by the developer. Anyone in the team can make mistake during the phases of software development. So in terms of a team, it means we have a lot of people working alongside before testing can be done. So let me take an example of the mobile app that the mobile application that you want to test a mobile phone. The first thing you need to know is that someone has to understand what the client wants to do in terms of what are the requirements, what does the client want, what do I want to, what are the expectations. So the client gives the requirement and the understanding to, we've got a product owner, we've got the business analyst. They gather the requirements, they have a bigger picture. This is what the client wants. Now they come to us to relate it, to say, oh, this is the requirement we've got, this is what our customer, this is what our client wants. The developer, the tester, we all get involved. And it's done. After the requirements, we all have an understanding of it. Then we've got a developer. He develops everything and sends it down to the tester. We do it in phases. So if the business or the requirement is not well understood from the top, that's from where I'm from the business analyst before it gets to the developer, before it gets to the, so it means if there's any error there, then anything we are building, there's going to be an error there because there was no proper understanding from that view. So just taking that any mistake, and it could also be from the developer. He might or not, he might be understanding something different. And also it could be from the tester, it could be from any one of us from the team. So that's it. Examples of error, it could be from the business analyst, maybe may misinterpret or misunderstand requirements. The customers may provide insufficient or incorrect information. The architect may cause a flaw in the software design. People on the team can also make mistakes due to unclear or insufficient requirements. So defect. So do not forget, I said error is human mistake. Defect is an inconsistency between expected and actual results. Please always note these two words, expected and actual results. All through your testing time, as long as your tester, know and have it in mind, expected and actual results are terms that we use all the time. Expected. This is what I want to see in the phone. That is from the requirement. This is what is expected. Now that I'm using this phone, this is the actual thing I am saying. So expected, this is what I am expecting to see. But as at now that I am holding the phone, this is the actual thing that I'm saying. So always have it at the back of your mind. These are part of testing terms that we use. A defect in a software product reflects the inability of the system to comply with the specified requirements. Subsequently, prevent the software application from performing the expected work. So if you could remember, I said testing is the activity to ensure that something is working as expected. So if it is not working as expected, then we have a defect. So that's what is just. So if something is not working as expected, then you have a defect. So now I've taken the phone. The features on the leaflet that I was referring to me when I was in the phone booth, while I'm testing the phone, I found out that the features are not there. So then there is a defect there. And I'll bring it out. Oh, you said this is meant to be on this. Look at the leaflet you have given me, and it's not on the phone. I can't find it there. That is a defect. It's not working as expected. An error that the tester finds is known as defect. The defect is also known as fault or bug. So defect has different names that you can call it. Some call it a bug, native, and I mean maybe some call it fault, call it error, they call it failure, as long as it's not working as expected. So what is failure? It's the consequences of a defect. So once a software is not working as expected and you find a defect, then it's a failure. You can't continue with it. So it is a failure. So it's the consequences of a defect. It is the observable incorrect behavior of the system. Failure occurs when the software fails to perform in the real environment. So we have a test environment. So when I tell you, oh, the car, there are people that work on the mobile phone. Sometimes you don't have a physical mobile phone, so you have maybe like an emulator where you can test it and check it. Then other times there might be physical devices where you've got the endpoint where you can test. So all these are the real environment, the test environment, where we need to ensure that it's working as expected. Not to forget, a software tester, your name is the one on any sign-off, any product, because you are the one standing in gap as a user. You are representing the user. That is why you are a tester. So if you say you are the user, you are the one that is going to use the phone, and it's not working as expected, it means you as a tester, you have to know that yes, even despite the failure, you need to let them know these are the failures, these are the reason why I cannot sign off, this is the reason why I cannot put my name on it. So you have to state it out, put everything into pen and paper to say, I've tested it, these are the failures I'm having, these are what I've encountered on the way. So those are part of the things that we do as testers to ensure it's working as expected. So that's failure. Keeping software under control. As I've said, in the internship, is going to be more granular in terms of, I'll explain more. Today, we have lots to cover. So that's why I said, please make sure you are following me. Any question, just put it in the chat. We have people on ground that are actually ready to answer the questions. I will answer most of the questions at the end of the class so that we can have a consistency in terms of understanding the work. So keeping software under control, exhaustive testing of complex system is not possible. So you can't say that, yes, this is a complex system. Oh, I can test everything on this. I can beat my chest that there's nothing wrong with the system. Look, give me an example. If you are given a page, maybe a textbook, you are you are given a page to test, and you're told to read that page, pick it. Okay, fine. I'm given the textbook first. I've picked my own errors in terms of maybe someone is meant to write D, that's THE. It was typed as TEH. That's my error. I get like 10 of the errors. That's me. Oh, I found a lot of bugs there. Now take the same book, that same page that I've finished tested and is corrected. Give it to a tester B to pick it. He or she also is going to get his own bug. Now close it again, fix those one, give it to a tester C. The tester C too will find his own. So you can't beat your chest to say, oh, this is a finished testing. There's no problem with the system. So that's why we have a phase to say, learn to prioritize, which we are going there, priority and knowing what quality, what are the phase you have. It is possible to run every possible test, simple or complex system. So you can run every possible test. So that's why you're prioritizing, ensuring that, yes, this is what are the test cases, these are the test design, these are the things I need to test first, these are my boundaries, these are the things, these are the yardstick for testing. So these are the things that we put into consideration. When is testing enough? So these are two words. I'm testing, I'm looking at the risk. When is testing enough? So as you are testing, you'll be looking at the risk. I'm testing a car. What are the risks? Loss of life. Ensure the brake is working as expected. It has a horn. It's got 4 doors. It's got everything locked in. Testing, risk. Testing, quality. What is the quality? I've built a phone. What is the quality? A website is there. What is the test? You are testing it. You're also checking the quality. Deciding when enough is enough. Now, I've tested and I've checked the risk. I've tested and I've checked the quality. Is this enough? Have I prioritized testing? Hence, when is testing enough? So, general testing principles. General testing principles. So, we have 7 of them. And the first one is that testing shows the presence of bug. If you all agree with me, testing shows the presence of bug. That is the reason why we are testing. The reason why we are testing is to find the error before it gets out to the consumers, to the customers, to everyone, to the public. That's the reason why you are testing. So if you don't test before it gets out, then it means you've just put people's life at risk. You've put businesses, you've put users at risk. That's why we have to test first to ensure that it's working as expected. So testing shows the presence of bug. Exhaustive testing is impossible. That's what I said before. It's impossible for you to test. And hence, we are going to prioritize our testing. When I mean priority, what are the risks? This is a website. This is a car. What are the things I'm meant to test properly? Before I start moving to the windscreen to do that, the first thing I need to check, is the brake working as expected? Is there a horn? Is the safety okay? Can I drive this car? Does he have an engine? These are the main components to test for in terms of prioritization. Early testing. Early testing. We are going to go, early testing is, as you have they've started building the website. The first thing is to do the login. You start, before they even start testing, before they start building, early testing is good in terms of reading the documentation, ensure that I have a tester has a proper understanding of the project or the product that is coming out. So we all do a kickoff meeting, inclusive of the developer, the business analyst, the project manager, every one of us in the meeting. At this phase, you have an understanding of what the product is. So once you start early, so from there, you can start looking, oh, what are the boundaries? This is a website. These are the common things. You go, you do your researches, put them down. Once the requirements start coming, you start building up your test cases, doing your expected, waiting for your actual result in terms of when the whole thing comes out. So that's why early testing, we are still going to deal more about early testing. Defect clustering. Where are the defects? What are the defects in terms of where is it clustered? What are the things happening in terms of defect? The pesticide paradox. It doesn't mean that, oh, pesticide paradox, you are testing, as I've said, a page. When you test and test and test, later on, you won't, if you are reading the page, very soon you'll just be skipping the line. Oh, I know what is going to be on that line. So leave it, there's no error there. By the time you skip 10 lines, you'll find out that those 10 lines have the major errors. So it doesn't mean because you repeat testing on a particular content or a particular product, it doesn't mean that, yes, it's error-free. So that's it. Testing is context dependent. So definitely we put in some things in terms of test data to ensure testing is achieved. So absence of error fallacy. You can, as I said, you cannot say, oh, if I finish testing now, there is no error. It's impossible. So you can't tell me that, oh, when you finish testing the car, if you put it out there and someone is running is at the speed of 250, nothing will happen. You can't beat your chest on it. So that's why there's a speed limit, there's a process, there's a manual to say, oh, run at this certain speed. So you can't beat your chest to say this, there is a fallacy to say there is, because there is no error there, then it's working as expected. No. All these, as I said, we've got more time to do majorly, or there are a lot of things inside these general testing principles. Always have it in mind. These questions come out when it comes to interviews. You could be asked, oh, what are the general principles? Just name some of them, have it at the back of your hands. Early testing, defect clustering, absence of error is a fallacy. So now, fundamental test process. So these are two words that they are in stages, 5 stages. So now, take example, if you want to build a house, the first thing when you want to build a house is to lay a foundation to ensure, yes, everything is ready. I want to build a house. Oh, these are the bricks. These are the what I'm going to lay in the iron. Everything has to be ready. So the first thing you want to do before I can build a house, we need to do planning. What kind of house can be built on this floor? What kind of house do we have around this environment? Can it take this? So there is a planning phase. When the planning phase is done, then we'll think, oh, now we can build a bungalow on this land. When you finish the planning phase, then you need to know, oh, this is the design, this is okay, we have said this is good, it's a bungalow, so we know. Then we start designing. What type of bungalow? What do you want it to entail? After you design it, then you need to put it in action. Then we start building up the bricks to say, oh, this is how I want it to be. After that bricks is done, then there's a time to say, we are finished now. Let's start roofing, and we have finished everything. We have completed it. Everything is installed inside the house, and we are done. After you're done, then you need to pick out of everything. Is this left? This? Then you have closed and say, oh, this house is ready for people to live in. The same thing goes as testing process. What are the bases? How do I start? Where do I start before I get to say I am done with testing? That's the phase we are moving on. Fundamental test process. So take it. First one is test planning and control. I said the first thing is for us to design when we are building a house is to plan what is going to be there. Now, we have been told mobile, we have a website that we want to do. Oh, yes, a website. The first is to plan. How do we want to test this website? What type of testing am I going to do on this website? Then you put in, that's where you're doing your planning and control. The second one is the test analysis and design. Where is the test analysis? Now, the test analysis, oh, this is the design I want to put it. That is where my test case is coming in. I'm saying my expected, I put my test condition, my test cases, my expected result, my actual result, and my status. So now I'm designing, I'm waiting for them to tell me. Now we'll start implementing. When we want to start implementing, this is it. I'm putting this implementation, these are the steps that we're going to do. This is it. Okay. Now my actual result is this. I said in the mobile phone, it should have a search button. Yes, now I'm seeing the search button. I'm executing it. As you're implementing it, you have written your own test cases, you have designed it down. Now I want to start executing it. Is the search button on the mobile phone? Yes, the search button is there. Can I end the call? Yes, I can. Can I start the call? Yes. I'm looking at it and I'm executing it. Now, it says evaluating exit criteria and reporting. Exit criteria, exit, stop, out, I'm finished. That's exit, stop. So that is where you're going out. So I'm ending my testing. So now, what is it? I've ended it. We have written our test cases. I've executed it. What is the result? Take an example. I've got five test cases to run. And in the five tests that I've written the test cases, I said 5. In testing, we don't always count to say, oh, you've written 5 test cases. So if, for instance, you have 5 test cases written, you have executed it, and that's the number 3 level, test implementation and execution. You've executed, and 4 of them passed. 1 is left. We don't say 4 pass. You have to put it in percentage. We have 5, so that is 100%. Each of them will be 20, 20, 20. So that's 100. 4 failed, so it means 80% passed, 20 failed. So once you say 80% passed, that's fine. The person can calculate, oh, 20%. If it's 3, then you say 60% of the test passed, and we've got 40. So these are reporting mode. So at that phase, there's a yardstick, there's a milestone that they want in the organization that you're working to say, oh, maybe when 80% of it pass, that's fine. But the first thing you need to know before you can say it's fine, the risk, the quality, have been prioritized. Because if you tell me it's only the cosmetic that passed, there's still a risk out there. So there would have been some things done in terms of that. After that, then test closure activities. Then we can say, oh, we finished testing in terms of documentation. This is what we have done, 80%. These are the bugs left. These were the bugs opened. These are what we are left. So all these are part of it. More into details. The psychology of testing. Any question, please move it into this. So psychology of testing. So there are different people at different phases when it comes to testing. We pull different from different fields to help the total testing effort. So you can be a developer, you can be some professional tester, you can be specialist, you can be performance tester, and all the likes. Anybody can test, as I've said earlier. So you can bring people in to just assist testing. It's not rocket science. Now we go to learning, our learning objective for this next chapter. So hence, we finished chapter 1, which the major thing about that was for me to let you know and have an understanding, a background of testing. What are tested? What are the principles? What are the fundamentals of testing? So that's why I used all those examples just for you to have an overview that how testing is done. Always remember, everybody tests. There is nothing new that we won't be able to see around in terms of example to give. So software development life cycle, different models of software development life cycle, that's the SDLC, then the pros and cons, that's advantage and disadvantages, then concepts in understanding testing. So software development life cycle model. So what this is just literally saying is how the life cycle of even human, let's say, of course, a baby is formed, from there it grows to this, it grows to that. So that's a life cycle. The same thing with testing. As I said, is part of us. Whatever we are doing in testing, everyone tests. In one way or the other, testing is performed by everybody. So Waterfall, Iterative-incremental development model, Agile. So that is where early testing comes in. You will know spiral, V model, Big Bang model, and the RAD model. So majorly, I only gave these are just, there are many examples, but we concentrate mainly on the waterfall, which is the linear mode, the V model, which is the sequential development model, and the iterative incremental models. So that's the software development lifecycle. Now, you could be asked in an interview which environment have you worked? Majorly now, we all talk about Agile. You must be Agile. Everything about it is Agile. And what is Agile? I said early testing. So you kick off testing right from the time they say this project A is going to begin. Testing begins. So waterfall, V model. So these are the three software development life cycles we actually work on. Now I go waterfall. If you look at the design, it's just like a waterfall. Hence the name of this model is like a waterfall. But in the waterfall, you can see it's just going down. It's not coming back up. It's just going down. So what it means is that at each of the phase, nothing. There must be a completion here before you can move to the next one. So we have the requirements, we have the design, we have development, we have testing, we have deployment, we have maintenance. So at this place, once if requirement is not completed, you can't move to design. So requirement must be totally completed. So BA just needs to gather out the requirement. Nothing can be after if she doesn't finish gathering a requirement, his or her requirement. Nothing can be done. So we all sit and wait until that requirement is gathered. After then, the design. Once he finishes it, he or she finish gathering the requirements, is then to designs. Then design to have to finish everything before it can move to development. Then development finishes before it can move to testing. Deployment finishes before it can move to this and that. If you remember, I said error, defect, failure. Error has different levels, which it could be caused by BA, it could be from the old team, it could be by the designer, the architect, it could be from the customer. So now tell me, the requirement, if now I don't have access to validate or to help out in terms of reading the requirement, checking that, then so if I don't gather the requirement and go, if the person, if the BA, the business analyst has gathered the requirement, and no one has actually have a review with the business analyst, and she sends it to the design. Now, if the design does anything from the requirement, even without understanding, and the design is done, do not forget, if there's any error in the requirement, if there's any error in the requirement, then there's error throughout to the maintenance stage. So I will, as I've said, I'll say the advantage and the disadvantage. Linear. This means that for each phase must be completed before the next phase begins. So which is requirements. User and business required are defined. Design, system design, architectural design are defined. That's each level, what is done at each level. The code is for the development, test plan, testing. So we are talking about the test plan, the scripting, the system testing, end-to-end testing, that's the phase. Deployment, that's the customer environment, that's what's done. Then maintenance, in terms of helping out customers with their environment, the issues. So what is the pros and cons, the advantage and disadvantage? So the pros, phases are processed and completed at once. Works well for smaller projects where requirements are very well understood. So it's just like you say, oh, this is just the 5 things we want to do. No changes, nothing is done. So if it's understood by everybody, it's fine. This will work. But when you have a big project, then at any phase, if you use this method, it's going to cost a loss. Don't forget, at every phase that you do this, sorry, so sorry about that. So at each phase, if there's any weight, or for us to, for instance, from the requirement to the design to that, don't forget, we are all part of the resources that form the project. So now requirements takes the next 6 to 2 months to gather. The design takes another 3 months, and we want to actually bring out this project in the next maybe 6 months. Even 6 months, it hasn't even gotten to testing. So how do you actually want to deliver to the client? So that's why if it's a smaller project, it's kind of easier. So everyone understands this. But the disadvantage, which is a con, is complete a stage before moving to the next. If something is wrong in the later stage, there is no chance of going back. Then it's an expensive model. So now this is V model. In V model, if you see the shape, is a V shape. So that's why it's V model. In V model, what happens in V model is at every point in time, there is a testing attached to every level. So let's take a user requirement, just like the requirement. So if you are doing requirement, then you've got an acceptance testing alongside with the requirement. We do an acceptance planning. If you've got a software application, you do the system testing. If you have the high-level design, you do the integration testing. And if you have, that's where you have the verification and validation. Verification, verifying that it's working, and also validating that, yes, it's working as the user actually wants it. Then detailed design. And that is where it is. So at this verification phase, so this time you are talking about the business requirement, business or user requirements, detailed requirements of the software system to be developed and gathered from the client. That's why I said about requirements. So we have people to go there, which are the business analyst, the project manager, the product owner, they have a view, a bigger picture of what the client wants. Now we have acceptance testing. With that, we have acceptance testing level. So at every verification phase, there is a validation phase. So if she gets the requirement, if the business analyst gets the requirement, an acceptance testing to validate, to say, oh, this is the test level. You have gotten the requirement. Ask for this. You said we want a login. What type of login details do they want? Do you want it? What kind of characters? All these are the acceptance testing. At the other phase, we take the software application design. We have a system test to check that. Also, the architectural level, in terms of design, we have the integration testing to do that. So also the module design, we have the unit testing, which is more of coding and the likes. So is coding, building the coding ethics, all these are part of the testing phase attached to each of the verification stage we have. So at this side is the verification stage, this side is the validation stage. So if I have a requirement, I will verify with a testing to ensure it's working as expected. I will have a software application system testing to ensure it's working as expected. And high-level design, integration testing, detailed design, unit testing. So incremental, this is now the Agile method. So what happens in the Agile method? I said early testing. So the first thing is in incremental iterative development method, what happens is that, let's take for instance, we want to work on a website application. Okay, I want to work on a website application. Take an example, maybe a Google app or maybe gift recharge app, anyone. The first thing is we've got users to be able to sign up if you have to do it. So what are the sign up? You want to sign up, you need your name, the first name, the last name. Signing up is a feature on its own. It won't be mixed with anything. In the Agile incremental phase, which is the iterative phase, is that once we know that yes, sign up is the first thing we want to do. The developer build the sign up. We all understand. First, the business analysts give us, we want to do sign up. These are the things I expected. These are the fields that you're going to add. Developer going, he does that. I've prepared my test cases down. Immediately he finishes, he gives me, sign up is done. I go there, I test the sign up of my test environment, ensure it's working as expected. Fix all the bugs. We come to a conclusion, do a regression testing on it. That's fine. Once that is done, that code is kept somewhere. We know now that sign up is done. The next thing we want to go on to login. We take login as a feature. We start all over again. Business analyst tells us, oh, this is what we have done. We are working on logging this sprint. And once the login is done, the developer goes there, oh, username, password, forget password link, all this. These are the things we want there. Once it's done, I'll be given again as a tester. I test that phase again. Once that phase is done, bug fix, regression testing, happy. That same code is kept somewhere else. We start doing it in bits and pieces until everything is done. Then we'll now bring them together. We are starting with signing, adding login, we integrate them together. That's when integration testing. So from component testing, component is, we have done sign on, is a component. We have done login, is one component, is one module. We have done fetch, is another module, everything. So now when we want to bring them together, that's the integration module. That is why early testing with us, Agile, iterative, is easier. We are a smaller mode. If we finish and the client wants us to change anything, it can be done immediately. And that is the way incremental stages. So each iteration passes through the phase. What is an iteration? And iteration is one thing I have said. I said, just sign in. We all get an understanding from the business analyst. He brings the sign in. Just do sign in. These are the features. It must have a first name, last name, email address, confirm password, password. That's the feature we want to be on the sign-in page. Once it's done, the developer builds that. Once the developer builds that, he sends it to EME, and I do the testing. And once that is done, we keep it. That is an iteration. Now, once we finish that in that sprint, we have another iteration, which is another sprint. So that's the way it goes until we finish up the whole sprint. So iteration output, partially delivered product. The product is repeated until the entire product development is completed. The repetition of these processes are called iteration. For every completed iteration, a project incremental is delivered. So we finished logging plus signing, login plus signing plus search button, login plus this plus that gives me until we get to the final stage. When is it used? This is needed to get basic functionality delivered faster. What are the pros and cons? Pros: quick deliverable to the market. Customers can provide feedback to each product increment, thus avoiding surprises at the end of development. So at this phase, there's no surprise. Everybody knows the signing. This is it. And once I finish it, I pass it all over to the client. This is what you have requested. Any changes? If they later on come with changes, we know this is a working mode for us. We just need to fix some bits. Then what is the con? Requires effective planning of iteration. So iteration mode, that's it. So this is what I said. Iteration, this is just a graphical face of it, just to show you that, from requirement to analysis, design, coding, then the product. That's one iteration. Now we go to this the second iteration. We move there. Requirements, analysis, design, coding, software. We go to the third aspect till we get to the final product. So this is iterative incremental development model. This is Agile. In Agile, we have majorly, we work in sprints. So sprint is like, as I said earlier, that we have a business analyst gathering information. We have project manager. All these requirements, all the specification gathered will be stored somewhere, which is in the backlog. It will be kept there. So in that backlog is like a house. That backlog, you have kept all the goods that we need to be able to move. So there, now in that backlog, we go there every sprint to pick what is the priority, what do they need as of today, what is the effort as the team. Don't forget, we as a team, a business analyst, a project manager, a product owner, a developer, a tester, a solution architect, if there are one, data analyst, it depends on the organization you're working. So we all are a team. So once we have the backlog there, then it's moved to the sprint. So sprint is majorly meant to be fortnightly. You must do it within 2 weeks. That's 10 working days. So that's how full Agile Manifesto, in terms of you reading forward to Agile, they've got Agile manifestos. So it's meant to be 2 weekly. But it depends on the organization. It depends on how the sprint is running, but it's meant to be 2 weekly. So That's from there now, what the Agile method and the way it is run is first definition of ready. Are we ready to go? Do you have everything you need from the client? Do you have a picture of do you have an understanding? Yes. Now, help us put everything in the backlog in terms of what is the project all about. Put it in the backlog. What are the things that you have gathered? Yes, it's in the backlog. From there, it moves from the backlog now. We now look, oh, in sprint one, what do we want to achieve? Sprint one, maybe, oh, let's start with infrastructure. What are the things that we need? We need test environment, development environment, everything that we need to get started. The foundation of that project, we need to base it on somewhere. We start with that, that will be sprint. So once we put that in the sprint, then it goes to development. Development, that is the developers. Now, we have 3 developers. We have X number of developers in the team. We all pick our tasks. Reason for sprint is to ensure that everyone is working hand in hand to achieve a goal, and we all have our tasks, individual tasks that we actually work on. So it's not that I'm working on logging and the same thing I'm doing, you two are working. But you can work on logging with different features. Yeah, that's fine. But not that I'm working on logging, the username. Another person is working on username. That's wasted effort. So that's the reason for sprint, to ensure that, yes, we are all working as a team to achieve a goal and to get everything done quickly to be able to deliver. So the development, now, once the developer finishes, it takes it to the tester. That's we, the testing team. Now we test, ensure everything is working, test script written, test plan execution. Now, after that is happy, we are happy. Then we'll put it goes to the integration stage. That's the coding stage. Oh, it is happy. Yeah, me is fine. That sprint, excuse me. Then from there, it moves to delivery. After the delivery is to the client. After we have checked, I put it in the prod environment, then they've checked. Oh, in UAT, this is it, user acceptance environment, test environment. So they now go, it moves down to delivery. So I've given it to the client. Once the client says, oh, yeah, everything is fine, this is it, yeah, that's what we want, then that's our DOD, definition of done. So we in Agile, we have a definition of ready and also definition of done. It goes from definition of ready to the backlog to the sprint, development, test, integration, delivery, definition of done. Now that's first iteration. We go back again to the sprint. Now we start again. Now from the backlog, how many things do we have? We are ready. We'll pick it again. Sprint 2. Go to here, development, test, integration, definition of ready. That's the way it goes. So now requirements, just an explanation and also a breakdown of what you're seeing from the picture. So is design and development, testing, implementation. That's build 1. Design and development, testing, implementation. Design till you get to the end build. So that's the way it just goes, each iteration. So we know in sprint 1, and it's easier. In sprint 1, we know we have covered this. The business know we have done this. In sprint 2, this is what we have covered. In sprint 3, it keeps it carries everyone along. Both the business, everyone understands that, oh, this is what we're actually working on. This is what we are doing on in the sprint. So it's kind of a transparent and visibility issue. This level. So we have unit testing, which is component testing in terms of testing in components. I said, test the sign-in first. That's one component. Go to the login, another component. Go to the search, another component. Go to each of the features. Those are, the codes are written for them. So integration testing, now bringing everything together. After you have integrated to share that, oh, this is sign-in, login, everything, let them come together so we can test it as a whole. And system testing, then acceptance testing in terms of you as a user. All these will be more in more details, more slides when it comes to the internship. Then we have test types, functional testing. Functional testing, in front of it is behavior. What are the functions in terms of how does what are the functionalities you're seeing? How does it work in terms of things that you can see? How you can see that yes, it's working. The mobile is working as expected. So all these are the features you're actually checking to ensure that you are doing, that is your functional testing. Non-functional testing, that's the performance. For instance, we are like maybe 71 here now, we are all using this together. Not to forget, if you build a website and we have like, let's take for example, Facebook. As I'm talking now, we have millions of people using Facebook at a time. That's where performance testing is. You're talking about the load testing, the stress testing, talking about the volume. All these are part of performance testing and is non-functional testing. Testing that, oh, after 1 million are using it, to billions are using this at a time, then it shouldn't break. Nothing should happen to it. So that's non-functional testing. Testing after code has been changed. That's regression testing. So for instance, you have found the bug, and once you found the bug, it's been taken back to the developer. He has fixed it. You need to retest, because when you retest, you are retesting to ensure that what has been fixed has not spoiled anything has not done any damage to the previous system and what it is. So that's why you are doing regression testing. Most of the time, you are being asked this question, interview question: what is the difference between retesting and regression testing? Retesting. I am retesting. So, for instance, you have said, let's take a login scenario as it. You have been asked to put your username and password. I put my username, password, and I click login. Then it takes me to the home page of whatever website I'm working on. That is a pass scenario. Now, let's give an example that, oh, I want to log in. I've put my username and I put maybe a wrong password. And when I put a wrong password, I'm also able to log in. And the expectation is that I shouldn't be able to log in. So the first thing is that you need to list the step to the developer to say, I'm able to log in with wrong credentials. So the first thing is, this is the URL. These are the things embedded in it. We are going to tell you how to raise a bug, all these, what are needed in the bug, all these I've said in the granular level in terms of understanding is going to be done. So with that, after you have done that phase, you have explained to him, he has now fixed the login. Now you can't log in with any credentials except the correct one. If you can log in with the correct one and find out that once you want to log in, the home page crashes. So the first thing you want to know is retesting. The only thing you are meant to retest is the bug that you have raised. That is the retesting. So now retesting, you are testing that I can log in without any credentials. I mean, I can log in without using the wrong credentials. So your test cases will be login, Yemi. My password should be Yemi, maybe password, and I should get the right thing. But if I log in with Yemi and I put ABCZ or 123, it shouldn't log me in. So if it's working as expected, that is fine. Now, your regression testing should now test everything in full. That when you log in, you check whether the features are working, everything that was built before is working. So remember, retesting is you testing the actual bug you have raised. Regression is testing to ensure the fix has not broken anything in the system. That's regression testing. So testing, just understanding testing. Testing verifies and validates that software or application is bug free. That's the essence. Testing identifies defect or bug. Testing helps to identify failure of software. That's all we have been learning since, just to emphasize on that. Debugging. Debugging is a process of fixing a bug or a defect in the software. Debugging is like you are correcting, you are fixing it. It's done by developers. It's done once you find an error or you find a defect, you send it to the developer. He will debug and fix it, send it back to you. Debugging removes error. Debugging identifies and analyzes and remove bug. So the next thing we are going to static testing. The types of static testing, dynamic testing. Static, staying there, I'm not moving. Static, dynamic, you're moving, you're checking it at different phases. So static testing. So static testing done when code is not executed, e.g. requirement reviews. So static testing, take for instance, after gathering the requirement, you want to test it. So you are looking at it, reading through, getting an understanding. You are doing static testing. No code is involved. Nothing. You're not doing looking at the code. It's just reading a document, ensuring that you have an understanding. Is there any error? Is there any loophole? What are the gaps? What are the risks? That's what you're looking. It's done at verification stage. If you remember, we said verification stage. Those are the business requirements, the design, the detailed design, the architectural design. Those are done at the verification stage. Code is being examined without being executed. So you can also, if you are a technical tester, you can look at the code, each line of the code, have an understanding. You're not running it, you're not executing it, you're not doing anything. That's the static testing. Dynamic testing is done at validation stage. Validation, yes, it is done. This is a dynamic phase in terms of looking at your acceptance testing, system testing, integration testing, component testing. All these are the validation stages. Code is being executed and tested without necessarily being examined. So that's it. Reviews and the types, the test process. So we have got different reviews that is done. If you could remember the example I gave, like if you're reviewing error, because you said error can be at any phase. It can come from both the business analyst, from the client, from the whole team. It can be an architectural flaws. All these are part of the errors that you could have. So if you want to review, I've given an example of you reading a content page. So if you read, if I've done my own testing on it, another person can review it alongside. You can have 2 or 3 reviewers just to validate what you have done. Because whatever you have tested, you won't be able to see your error. Others will be able to read and see your errors. So hence the reason why we have reviews and the test process. And reviews are done in different levels. We've got you can do a walkthrough. We've got the interpreter. We've got all this as part of the review levels. So that's types of review: informal, walkthrough, technical review, inspection. Walkthrough in terms of ensuring that you have an understanding. We are explaining to you. Of course, when you start when you start your new job as a test analyst, the first thing is that you request a walkthrough, and the walkthrough is in terms of you, of them explaining to you how the whole system works. You can't just get to wherever you're working and expect them, if you don't know what they are developing or you don't have an idea, you can't just do magic. So in terms of informal review, we're talking about documentation, requirements, all these are technical reviews. In terms of code review, inspection, checking everyone. So that's it. Now, I'm going to dwell on this. And please, if you've not been paying attention since or you've been off, this is the place, this is what a tester is all, a test analyst, our job is all about. This is it. Using, understanding test case design. So at this phase in the textbook, this is the chapter 4 of it. So at this phase, understanding test case design. So I'm going to take it in, give you quick examples of it. The first one is keywords that you should understand. Test condition, test case, test procedure specification, which we also call test script. Test condition, you could have been hearing me saying test cases since. This is the test case process we're going through now. Test procedure specification. So test condition. Let me give you an example. For instance, let me take it that you have gone to the GP. That's to the hospital. You want to see the doctor. The first thing, like in the UK, you will be asked by the receptionist, why do you want to see the doctor? Oh, I have headache. Test condition. So now we know it's headache. It will be written there. She doesn't want to know. Now she has registered the name that patient A is coming. The test condition is headache, is registered there. Now, before you get in, the doctor would have, your name is the next person on the queue. Oh, the test condition, headache. Now the doctor start building his own test cases. The first question I'm going to ask patient when he comes in, when you shake your head, are you having the headache? Those are the questions. That's the first question. The second one, when you look up, do you have the headache? No. When you move sideways, you do this. If I touch the head, do you have headache? No. These are his own test conditions. His test cases is written. They are in test steps to ensure that yes, this is it. So now, if his own test cases are, don't forget the condition is, I've come with headache. The first test case, if he shakes his head, is expected, the doctor is expecting to tell Yemi should say, no, I'm expecting you not to have headache. If I touch the head, the doctor is expected result, no, she shouldn't have headache. The other one, if I look up, the doctor is expecting to say, no, my doctor's expected result is, no, Yemi doesn't have headache. Then on the fourth row, don't forget the doctor hasn't called Yemi. He has only prepared his test cases and also his expected results. So what the doctor is expecting is that once he calls your name, you as a tester, your first thing is to make all those cases, design them down so that when the actual product comes in, you start testing. Now, I've called the patient, come in. I've done test condition. I've done the test cases. I've done the expected results. Now, patient A, when you shake your head, are you having a headache? No, doctor. Actual result, as the doctor is saying near me, is no. So it will say working as expected. I've seen it. Yemi is not having a headache. Now, the second one, if you look up, are you having a headache? No, doctor, I'm not having a headache. He will expect is this thing. Yes, fine. She's not having a headache. It's working as expected. Now, the third thing the doctor is expecting is that if you touch your head, are you having a headache? Oh yeah, I'm having a headache. The doctor will say, not working as expected, because his expectation is that the patient shouldn't have headache. at this phase, we now have a last set to complete because I've done the expected, and now the doctor is seeing the patient. So at the first one, when he said, when you shake your head, the patient said, no, I'm not shaking my head. There is a status. What is the result? The doctor will say, yes, it's passed. Is it pass or fail? Yes, it's passed. The next one, what happens when you touch the head? When you touch your head, are you having headache? Oh, yes, I'm having headache. The expected result of doctor is that he shouldn't have headache. But actually, the person said he's having headache. So what happens to the status? It has failed. That's an example. So I've done the test condition. I've taken the test cases. Now I've executed everything because I've seen the patient. That is my test procedure and condition. Now, my example is I'm going to just share my screen. And this is where, as I said, once I share my screen, in the next 10, 15 minutes, we'll be done with this class. Don't forget, any question, pop it in, and I will be able to answer. I'm sure my colleagues have been doing wonderfully well, so I will pick up the rest after them. So I'll share the screen now. One minute. So I'm going to use a website now, gift read. So sorry, I'm just moving into the website. I don't know. Where is it taking? So I'm just looking at taking a website just for me to be able to show you a clear example of how test cases are written, and you'll be able to use that to design your test script. So at this phase, before I show you this gift read, now, if you look at it, I said test case ID, test condition, test step and description, expected results, actual results, status. This is a typical high level of test case design. All these levels are needed when you are designing and writing your test scripts. So if you see, this is a test condition where I put the headache. This is the doctor's step. This is what the doctor is expecting, expected results. When the doctor was seeing the patient, this is the actual results. Now, this is the status, pass or fail. Once the doctor has done a pass or fail, this whole script here is what we call the test script. Is a test script after the execution is been done. That's what is called a test script. So is just an example of what is done. I'll just use it as a website. So gifttreat.com. Gifttreat is oh, it's not letting me go. I'm just trying to 1 minute, please. Sorry about that. So I'm sharing my screen now. Where's the share? New share. Share. Yeah. I hope you can see my screen now. So this is the Giftrit website. I use this as an example so that you'll be able to just have an overview. This is a website. So if you look at it, it's creating new and reusable gifts. And the essence of this is just to reduce waste and in our community. So you can actually give people gifts. So that's understanding what the project is, and you'll be told about it. And that's hence we have the about us here. But now today, I just want to make example from what we have done. I'm taking the sign-in as one of my components. So the first thing I want to do here is I'll be navigating through it with my with sharing of what I want to show. So the first thing I'll say is I've navigated to giftry.com. Now I want to take sign in. I've done sign in. When I click sign in, it's asking me for my email and my password. The first thing I will put my own email because I'm registered. But for you or for a new person, you have to go through the register link, which is there. But I'm using sign in as my example because I'm registered. So I've got my own password. So I'm logging in. So it logs me in. So I'm in the website now. So if you could remember, let me iterate the steps again for you to see. I'll log out again. So log out. So now I'm here, sign in. I've gone, sign in as EME, put testing, put my password. It could be password 1. I put password 1. I'm just saying, don't know what yours is going to be. Now, when I log in, when I click login into your account, that's it. I'm logged in into the account. Now, that's the happy part. I'm able to log in. So I'm logging out again. I'm going to do another one. Hear me. Now I'm not going to put it. I'm going to put just anyhow, any password. That is it. If you see, I just used any password. So I'm expecting this to give me an error. I shouldn't be able to log in. Now, when I log in, it says your login credentials are invalid. Please try again. So I've done the positive testing, which is the happy part, and I've done the negative testing. Anytime you're testing, you test the happy part. Happy part is always happy. The sad part is the negative part. So there are different scenarios. If I finish up here, if I don't put anything, when I hit the login, that's another scenario. To tell me, if you look at it now, the login, it gave me another error. It says the password field is required. So it's expecting me to put the password field. I can do 1, 2, 3, push show you. So these are several things. It says the login credentials in free. So these are scenarios. These are boundaries that we use when it comes to test cases. So I'll go back and share my screen again. I hope you can see my screen again. So now it says test case design. I said go to Giftrit website, www.giftrit.com. My expected is that Giftrit landing page is displayed. What is my actual results? When I logged in, was it displayed? Yes. I got the home page. I was on the landing page. I could see it. What will be my status? Pass or fail? Pass. Again, I went in there. I said, click get started for free button. Ow. I'll go back again. Get started for free. The sign-in page displayed. So is it working as expected? What am I seeing when I was logging in? The sign-in page is displayed. Sign-in page displayed. Working as expected. Pass or fail? Pass. Enter username as username@giftry.com. I entered my own username, username entered. Actual results, yes, I'm able to enter it. My password, I entered the password. Yes, it's working as expected. And when I hit the sign in button, the login button, what did it give me? On page is displayed. So what happens to it says pass. So when you look and everything passed, if you're asked, I've executed 5 test cases, which are for signing only. What is that's the only 5, and it's the happy part. I'll say test. When my manager asked, "Oh, Yemi, how have you executed your script?" Yes, 100% of it passed because everything. Now, when I do the invalid details, that's the different scenarios I gave you. In terms of entering wrong password, blank password, I can do 1001 scenarios for that. And the essence of you doing the negative testing is to break the system so that you are not the only one going to use the system. We have other people that can act, people that is going to break that system. So your essence is to break the system before it gets to the end users. So that's the essence of it. So now, which I've executed here, if you see. So this is my test script now. Because everything is done, is green. Working as expected, sign-in page displayed, username displayed. All these are working as expected. So, and that is my test script. Your test script comprises of everything after execution. If you look at what we have said here, we said the test procedure specification, which is we call as also known as test script, is a sequence of action for the execution of a test. So we have done everything completed. That is all the sequence, everything is working as expected. Now, categories of testing design techniques. We've got the black box testing and the white box testing. So specification based, that's black box testing, and also structural based, that's white box testing. So for this black box testing, you need to know 5 specification based technique. That's for this foundation certificate. For you to be able to test, there are things, and these are the categories. Like you are designing a house, you are designing your test scripts. These are the things they expect you to see. All these will be explained more in details because at the internship we'll explain it. You can read it up, and the 5 ones that you must know is always asked when you go for interviews. You will be asked most of the time: equivalent partitioning, boundary value analysis, decision table testing, state transition testing, use case testing. All these are part of the test case design, because these are actually what will make you will be able to design the actual test cases in terms of understanding what this is. In terms of equivalent partitioning, is where you have you've put your inputs, your outputs, you want to check, oh, what is boundary value, what is the equivalent partitioning. In interviews, you'll be asked what is the difference between equivalent partitioning and boundary value analysis. Boundaries, you are testing within the boundaries. Say, for example, you have 1 to 10, and you were told to test 1 to 10. Let me not use 1 to 10. 1 to 1 million, and you have to test 1 to 1 million. If you want to test 1 to 1 million within the boundaries, you can't just start testing number 1. You finish testing number 1. After you finish that, you go to number 2. You will not finish. That product will not come out at all. Maybe next 2 years, by the time other ones have come out, that's when you will finish testing. That's the reason we have to design. We have a category of designing our test cases. Those are this type of designs to ensure that yes, these boundaries are actually achieved when you are testing. These are things you put into consideration. When you're putting your speech, when you're talking in interviews, you design your test cases with test case design techniques such as equivalent partitioning, boundary value analysis, decision table. All these are part of the speech you say when you are actually doing an interview. They they know that yes, you understand what you're doing. Now, the question is, when you're asked, how do you test within the boundary? How do you use equivalent partitioning? If you can't, then you know it's another phase. So that's why I said I'll discuss that in the internship, but I'll just give you an high level of it. So the boundary, say for instance, 1 to 1 million, we want to test it. The first question is 1. We want to test within 1. When you're testing within, okay, you test 0, you test 1, you test 2. If they're working as expected, move to the middle. 500,000. You want to test 499, 500,000. Then you move to 501,000. You move to 999, 1 million, 1,000,001. Those are testing within boundaries. Decision tables are true or false. Do you want to, in terms of validation, true or false? These are decision tables. Then use case, testing one to many. Looking, maybe you get an actor, you're testing one to many. So these are examples of test case design. This will be explained more in the internship. So the structural base, which is whiteboard texting, so is used to explore system or component structure at several levels. At component level, the structure of interest will be the program structure, such as decisions. The integration level, we may be interested in exploring the way the components interact. So whiteboard is majorly at integration level, checking the codes, the components, ensuring these are things that are behind. So that is white box testing. So categories of test case design, we've got experience-based testing. Experience-based, I've told you earlier, if you want to test experience-based, it falls back on the experience you have. If you have tested a web application before and you go to another company, you have an experience in that. So you'll be able to know the test cases to build on, what to look, those are the experience-based. Error guessing in terms of what are the advantages, the skills of the tester, or you have used this before. Just these are two-way things in terms of guessing. This is what is expected. If you make a research, you'll be able to get that. Then exploratory testing is done. Oh, you have used exploring the system. What does it mean to explore the system? For instance, in terms of I've not used the system before. The first thing is that you want to play with it. You want to get an understanding. You want to explore the system. How does it navigate? Where do you go from this and that? That's what you're doing. You're exploring. So that's is the of today's class, and we'll start the next learning from this, which you will understand basically. Now, any question in terms of that? I'll read more of these in the chat and I will answer the questions. So what's a bit different between test case and test script? So someone is asking the difference between test case and test script. So if you understand, test cases are just the steps. Each of the steps that you're going to take to do it is more of a test case. You are gathering the tests. Test script is that you have executed it. If you look, let me give you an example of this. This is a script. been executed, is done. You could call this is what you are designing. This is your test case design. This is what you're getting, all the things you are expecting. You want to execute a project. You already have understanding. So these are the test cases. So you have built all your test cases, but you've not executed it. So your test script is when you have executed, done everything, you have finished it. This is a test script. So more again, difference is not clear. I can't hear well. Oh, sorry. Agile sprint is more focused. A project is broken down into more series. Okay, yeah. So yeah, I think my colleagues have been doing kind of a lot. Retesting is testing. Yeah, thank you so much. So I think majorly. So could we say test script is an executed test cases? Kindly explain equivalent partitioning once again. Okay. So someone said I should explain equivalent partitioning. So majorly equivalent, if you know, I've said boundary. Equivalent partitioning is based on a very simple idea. It is that, so when you say is that in many cases, the input to a program can be chunked into groups of similar inputs. For example, if let me take a real example of 1 to 10. So when you're doing equivalent partitioning, you are testing to ensure that yes, everything is covered in terms of your test cases, in terms of your input, in terms of each of the in terms of you prioritizing, ensuring you have covered everything you are testing. Because I can use 1 to 10, it's small, so you can actually test it. I can use 1 to 1,000. So at this case, when you test it, you need to test it to ensure that yes, these things they are working as expected at each level. So you will have to move down a bit, also to the equal part, and also ensure that after the equal part, you are moving out of it. Take example 1 to 10 again. I'll tell 0, 1, 2. 0, I'm equal at 1 because they said 1 to 10. And I will test 2. If this 3 works, subsequently it means 3, 4, 5, 6 will work. But even if we want to take it harder, just to ensure that yes, it's working, I can stop at 4 and take 5 and test it, and take 6 and test it. But because I'm just saying 1 to 10, then if 5 and 6 works, it means 7, 8, 9 is going to work. Now let's test within 9, 10, and 11. Just to ensure that you are covering everything. Don't forget, I said a software tester, you must think out of the box. That is why we are designing those techniques. Please, how does the BA get involved in acceptance testing, and how do they work with the tester? The BA gets involved with acceptance testing in terms of when they get the requirements, before you can test, you would have built your test cases. Let's take the login scenario as an example. In the login scenario, you have your username. Most of the time, some people say username or email. Now you need to clarify, how are we going to log in? Is it with both the username or the email? That is one of it. So now acceptance criteria. The BA, once you have this, you put it on the table. Acceptance criteria, username, what are the expectations? So your username acceptance criteria will be username. This is what comprises of username. Email, example of the email. This character, it can accept special character, it can accept anything. That's for the email, but it must be an email, a correct email. And then password. What are the things embedded in password? Lowercase, uppercase, special character, letters. All these are part of the things that will be involved. So both of you can decide. But sometimes BA gets involved in acceptance criteria. If they are not involved, whatever you put as your test cases can be used as a yardstick to do it. So it's a two-way thing. Both of you can work together, and if it depends on how big the project is and also how occupied the business analyst is. So you can do both together. To it. So does it mean that BA tester and software that work? Correct. They work as a team, Ruth. So which means that the BA tester, software developers, we all work together. That's why I said, even project manager, product owner, they sometimes we are not client facing, and you could be client facing in terms of maybe third-party vendors, maybe speaking to them on testing. But the person that has the bigger picture of it, that has understanding, is the BA project manager. All those, so we all have to work together. So if they have bigger picture of it, they need to bring it down to us to tell us, this is what I want you to be, this is what the client is expecting, and that is it. So we all work together as a team. What else? So let me look at the questions again. Okay. Well, I hope all the questions, since I'm sure the questions have been answered. So I want to say all the questions have been answered. Great. So all the questions have been answered. Thank you so much. So in the absence of these questions, we'll end today's class, and I'll hope to see you all in the internship, which will be more granular, more easier, broken down into, well, understanding with various examples. The next class is going to be with my colleague. She's going to teach you on some of the tools in terms of test plans. Somehow, all these are going to be coming handy for the next class. Well, I wish you all the best in case, and I hope I'll see you in the internship. And I hope one of these days we will be colleague at our field of studies. All the best, and thank you all for tonight. Goodbye.